Hello everyone. Am I audible? Hello, am I audible? Okay, looks like I'm audible. Yeah, so let's start this. Yeah, good to see you later. Audible. So before starting the PCD, there's we will talk about the CP31 sheet by TLE Eliminators. So as you guys have been looking at the PCD that is provided by TLE Eliminators for free for the community. Similarly, TLE Eliminators has a CP31 sheet as well. This is also free for everyone, completely free. And it is having basically a CP31 sheet is a sheet having multiple problems for every problem difficulty. And the problems have been handpicked by Priyansh, or they have been picked by very high rated coders, candidate masters, or higher. Like the least rating would be candidate master for the ones who would be picking problems. And even then, the problems are reviewed by Priyansh. So basically, it's sort of like a guarantee from Priyansh that the problems would be really good to practice. And let me give you an overview of the 31 sheet. So if you come to the TLE Eliminators website and click on here on the top CP31 sheet, then you will get to this page. Here you can connect your code forces ID. You will see a button around this place uh, to just enter the name of your account so that all the problems that you have solved would be marked in green. Like all the problems that I have solved um, from this rating are marked in green. Obviously, I didn't solve it for the 31 CP31 sheet, but I had already solved this earlier, and they have picked up almost all the good problems for every rating. So you get some features here, like if you solve a problem and maybe like you tried a problem and you were not able to solve it, you want some editorial. So obviously, the first thing that you should do is to upsolve it by yourself only. Maybe look at the text editorial given by the problem setters or basically the editorialists, or maybe try to search about the solution for the problem online. But if you are not able to find the solution online, or you could not understand it, then the solution given by TL eliminators would be just shown at the same place where the problems were given. So you won't have to search for at least the solutions given by TL eliminators. And all the solutions till now have been created by Viraj, and he's a really good teacher. Like he explains all the problems really well. You get some more features, like you can add notes for a problem. Maybe like I tried this problem and um, I thought about some approach for a long time, and it took me let's say it took me 30 minutes to solve the problem. And after solving it, I realized the mistakes that I made. So I can just mark down the mistakes here, or I can mark down some other things that I want to remember in future if I come back to the problem. Obviously, the statuses would be updated by themselves if you link your code forces ID. Otherwise, you will get a tick option here. Though I would recommend you to connect your code forces ID here. And here you have some buttons to mark some problems with revisit. So basically, you would know that you want to come back to the problems later on. And then there is a discussion section here, a discuss tab, where people who have been trying the problem, so basically who have been using TL Eliminator CP31 sheet, can write something. So it's basically like some community support. Maybe you have some doubt that you want to ask. So you can just ask your doubt either in the discussion section here, or if you want, you can just go to the YouTube video and ask your doubt there. And you will see other people solving your doubts and explaining them to you. So that's also something you can take advantage of. So uh, let's move on to the PCD part now. And by the way, for the CP31 sheet, you will find the description. Sorry, you will find the link of the sheet in the description. So for now, let's move on to the PCD. The very first problem of the Leetcode contest is calculate score after performing instructions. This problem says that we have been given two arrays, instructions and values, both of size n. You have to simulate a process based on the following rules. Initially, we start from the first instruction at the index I equal to 0 with an initial score of 0. If the instruction, if the ith instruction is add, then we will add the value on values of I, basically the um, value of the ith index in the values array, and we will move on to the next instruction. And in case if the instructions, if the ith instruction is jump, then we will jump like values of I number of times either ahead or behind, depending upon what is the values of I. So if you have this thing as positive, then you will move towards the next instruction. Basically, I will increase, otherwise I may decrease. And we will keep on doing this thing until either the value of I goes out of bounds or we try to revisit an instruction. Basically, something like this might happen that I was initially 0, you moved on uh, to I equal to 4 by performing some instructions. And later on the fourth instruction was to jump 4 steps behind and you reached I equal to 0 once again. So in that case, since I equal to 0 has already been executed, you will just stop. You will not execute the instruction and you won't try to execute any more instructions. We have to return the score at the end of the process. So let me show this. Let me show you the dry run of this test case. Why can't I paste it? Oh, nice. Yeah, so this is the A problem. And as we discussed, we will start executing these instructions. Initially, I would be equal to 0. If the so if the first instruction, like in this case, is jump. By the way, let me mark the indices here. Yeah. So currently I is equal to 0. So we will jump 2 times. So here I would be incremented by 2 and I will become equal to 5 here. Sorry, I will become equal to 2 here. My bad. Yeah, I will become equal to 2 here. Now, um, on I equal to 2, we have add. So we will add the value here. So for I equal to 2, the answer, or basically the value which was initially 0, will now get incremented by 3. So answer will become equal to 3 now. And I would be incremented whenever you execute the add instruction. I would be incremented by 1. So I will become equal to 3 now. Now on the instruction with index 3, you have jump with value 1. So for while executing instruction with I equal to 3, you will just add 1 to I and your I will become equal to 4. 4 is an add instruction with the value 2. So actually it's -2. So answer would be incremented by -2 here, due to which answer will become equal to 1 and I would be incremented obviously. So I will become equal to 5. Then 5 is a jump to 3 steps behind, which means I will be decremented by 3. So I will become equal to 2. And for the instruction on 2, we have already executed it. है ना? We have already executed this instruction. So we will just stop for now. And at the end of the day now, answer is equal to 1 here. And that is why our output would be equal to 1. So they have shown the dry run here as well in the example. And in this problem, all we have to do is just simulate this process of how the things are going. Like we just have to keep track of the two things, this value answer and the variable I. There is no logic part for the problem. Like we don't really need to think much by ourselves. All we need to do is just simulate this and code this. The constraints here are not too small, not too big. So let me just show you the code for this problem. We don't really have much to do. And I believe everyone would have already solved it. Is there anybody who could not solve the problem, by the way? I'm thinking why level 2 and level 3 is self-paced, and I would like to hear all opinions. It's up to you, like which one you want to buy. In my opinion, um, maybe buy one course first, and later on buy the second course if you feel you're able to cover the first course completely. Since in the self-paced course you can go by your own speed. So if I was at your place, I would first buy the level 2 course, complete it, and then go to the level 3 course. Okay, let's look at the code for the first problem. What I did is I kept a variable answer and the variable I, and I have a while loop which will go until I is not out of the bounds and the ith instruction is not visited. I created a visited array as well. Basically, whenever I execute an instruction, I will mark it as visited. Maybe I can write it here for better understanding. So what I will do is for any ith instruction, I will see if it is an add instruction or a jump instruction and do whatever we had to do for these two instructions. And later on, I will mark the instruction as visited. Basically, I will have a visited array in which I mark that, hey, this instruction is visited. Now, in future, if I ever come back to the same instruction which has already been visited, I will break the for loop. I will break this while loop. Similarly, if I either goes below 0 or it becomes greater than equal to n, in those cases as well, the while loop should be broken. So I have these conditions in the while loop, like the condition brackets for the while loop. And here I am executing these instructions and marking them visited. That's it. As for the part of time complexity, there can be at most n iterations for this while loop. So overall time complexity should be big O of n at most. And I'm creating a visited array here of size n, so the space complexity would also be big O of n. So guys, please tell me whether this problem is clear or not. Shall we move on to the next problem, or do you want to ask something regarding this problem? And let me read the chat till then. If you want to buy a course or buy a level for only one topic, then this is something not really recommended. Like it's up to you. Um, but if you see, even Priyansh says that, like while recommending the level, he says that if you know, like 50% or more than 50% of the topics that would be taught in that level, then maybe go for the next level and not for that level. That is something that even Priyansh recommends. If there is just one or two topics that you don't know about from a level, then just go for the free resources online. Okay, let's move on to the second problem then. So the second problem is also a simple problem. It says that we have been given an integer array nums. In one operation, you can select a subarray and replace it with a single element equal to the maximum value. We have to return the maximum possible size of the array after performing zero or more number of operations such that the resulting array is non-decreasing. A subarray is a contiguous non-empty sequence of elements within an array. So like here, let's take the example of an array 4 2 5 3 5. Yeah, so here's the example. Let's say, like in the B problem, what we have is we would be given an array. We want to make this array non-decreasing. Basically, we want to sort it in a non-decreasing order, or like not really sort it, but just make sure that the array becomes non-decreasing. For doing this, what we can do is we can apply a type of operation. In operation, we choose a subarray. Let's say the subarray is 4251. Now what we do is we pick up the maximum element of the subarray and replace this subarray by just one element that is equal to the maximum value of the subarray. This is what happens in one operation. And what we want to do is, while making sure that the array becomes non-decreasing, we want to maximize, or we want to find out the resulting array with the maximum size that we can obtain. Maximize the size of the array. So this is the goal, right? Make it non-decreasing while making sure the size is as big as possible for the array, as much as we can. And that's it. So we will have to return the size. Right. Next, the next thing is like what question saying different events can I, how do I start DP graphs? Any tips? For starting DP and graphs, we will discuss about it after the problem. Okay, so for now, this is the problem. I hope everyone is clear with the problem statement at least. Now let's take one example for understanding what we want to do. Like let's say the array is 4, 2, 5, 3, 5. So see, whenever you apply an operation, you choose a subarray and keep only the maximum element, right? So for for a non-decreasing array, whenever you want to create a non-decreasing array, the thing that should come in your mind is the values on the left are small, है ना? And the values on the right are larger. They are bigger than the values on the left. Now by applying an operation, we can't really make the right guy bigger. है ना? We can't really make the right guy bigger, nor we can make the left guy smaller. है ना? So there is nothing like um, we can make the left guy smaller or right guy bigger by applying an operation. So like I do check for this kind of thing because in a lot of problems where we have different type of operations, sometimes we can make elements larger. So what we want to do is make the elements on the right side bigger, but we can't really do that. So right now the thing is, whatever value is present on the leftmost position, since we can't really make it smaller, and we have some other values that are present right after it. Like we have 4 at the first position and 2 at the second position. We can't make this guy larger than 4. So what we can do is we can maybe apply an operation on this range. So both of these elements would be replaced by 5, which is basically equivalent to saying that you will delete this element. है ना? This is equivalent to saying that you will delete an element. If you are choosing a subarray on only the largest element will survive, then it is equivalent to saying that you will delete the smaller elements. है ना? It is equivalent to saying that. So um, for the first guy, if on the right hand side you have someone greater than this, then that's really good thing. Otherwise, if there is a smaller element than this first guy, then you can just apply an operation on these two people, right? You can just apply an operation on the first two people. So technically this guy would be deleted. Now what will happen is you will have the new array as 4 5 3 5. right? Now again check the first two elements. Here this guy is greater than the first element. So we don't really need to delete any of these elements. We are having the non-decreasing order here. Now we will check for the next two elements. Now if you find out that 3 is actually smaller than 5, so you would like to delete this 3 because the kind of operation that you have is pretty much similar to deleting the smaller element. है ना? This operation is pretty much like choose a subarray and delete the smaller elements other than the largest element. So the most flexible way of using it is like choose two elements and delete the smaller one. So you can have that kind of thought process that just you can delete the this guy as well. And now the array would be 455. You know the first two elements are in the correct order. So that is why we are checking for the next two elements. Now these are also in the correct order, so you won't do anything and would like to check for the next two elements. But this 5 is the last guy and you don't have anyone on the right hand side to check. So you can just skip and you have got the um, non-decreasing array, and we have applied operations only in the situations where we actually need to apply. Like wherever we are having the situation that the left guy is bigger and the right guy is smaller, you need to remove the right guy. That's mandatory for you. So do you guys feel that we are just going greedy? We are going in the greedy way and we are deleting only those elements that are really necessary to delete. Without deleting them, we can't obtain a non-decreasing array. Apart from that, we have not deleted any element. So here we will have the largest array with non-decreasing order. Another thing to note here is that this problem is basically asking you, like this problem can be treated in this way as well, that um, like in the new array that you will have after all the deletions, the first guy is obviously gonna be the first guy from the original array. Because if even if it is the smallest element, in that case as well you won't delete it. And if it is even a large guy, you can't really delete it. है ना? If there is a smaller guy on the right hand side, you will delete the guy on the right hand side, obviously. So the first guy should come for sure. Then what you will do is whenever the next larger element comes or the next guy with the same value comes, only that element would be put in the final array. Other people in the middle would be deleted for sure. है ना? All the people who are smaller than this guy who comes in the way would be deleted for sure. So can I say that you will just start from the first guy, find out the next larger or greater element, then again you will just find out the next element which is greater than or equal to the current element, and you will just keep on the count of how many elements you found in this way. And this is another way of thinking about the problem. And there can be many more ways of thinking about how to solve the problem. I tried to explain it in the simplest way I could think of, um, a way which even a beginner could think, or at least a beginner can understand. Um, for solving the problem, I tried to remove all the complications. So, would you guys like to give me some feedback about this? And if you feel that there is some other even simpler explanation that you want me to cover, then you can give me an idea. Okay, this was your exact intuition. That's great. Okay, very well. Somebody asked why we cannot delete 4. Yeah, so see, the point is for the first element, if this guy is greater than the next guy, in that case, when you apply an operation, this guy would be deleted, right? This right guy would be deleted when you apply an operation, because only the maximum element will be left and the smaller elements would be removed. And if this guy is smaller than or equal to, then applying an operation will delete it. But this is actually useless for you to delete this guy because you are unnecessarily decreasing the size of your array, and you are getting nothing because this is actually the order that you wanted, a non-decreasing order. So there is no point of deleting the first guy. And let me read the other messages. Uh, 4 2 2 5 5. Okay, so if you have an array like 4 2 2 5 5, then what will happen is, first of all, you will have first, like you will compare these two elements, or basically you can compare any two elements of your choice. The point is, the left guy should be smaller than or equal to the right guy. So even if somebody had started from the end, he would have got the correct answer. But for simplicity, for explaining the problem in a simple way, we are starting from the left hand side only. 4 is greater than 2. So you will need to apply an operation here. 2 would be deleted. Now the array would be 4 2 5 5. You will again have to apply an operation here. 4 5 5 would be the new array. Now 4 is smaller than 5. 5 is less than equal to 5. So you're not having any complications here. So you won't delete any more elements. And that's it. We have got the size 3 here also. Okay, somebody said if intuition was stack and did only two problems, then be careful. Your code has some pairs and repeat problem. Yeah, somebody had actually suggested stacks for solving the problem. It's not really required. This was my exact intuition. That's really good. If we find larger, if delete 4, but you can't delete 4. Karan, the thing you're saying is actually good. If you delete 4, then you will have a larger array. But the point is, the operation that we can apply is choose a subarray and keep only the largest guy. And replace the subarray with the largest guy. So uh, for solving the problem, I have simplified this operation into a way that you're picking up a subarray and deleting the smaller elements. है ना? And for simplicity, you can say that instead of choosing a subarray of size 4 and delete 3 smaller elements, you will never do this thing. Instead, you will just choose two elements. Basically, you will just always choose neighbors and delete the smaller guy. In that way, also, you can do everything that you could do with the earlier operation. And um, the way of thinking will just become a lot easier. Um, yeah, somebody said that we can also do by finding the next greater element. That is what I had told here also, that my thought process was also the same. That I will start with the first element and I just want to find out the next element that is greater than or equal to the current element. Um, but I don't know whether everyone would be able to get this kind of intuition or not. That is why I went with what we can do with the operations. How do you start DPN graphs? Yeah, so for the one who is asking how can you start DPN graphs, what I recommend is, first of all, you need to know about the theory a little bit. So go to Stiver's channel maybe, or some other creator of your choice. In my case, I had went to Stiver's channel and watch a few videos. You don't need to watch the complete playlist. In my case, I watched the first few videos, maybe like 4 5 videos or so, and then start solving problems by yourself. Try to solve the problem by yourself first. If you can't solve it, then maybe watch the video, or try to search about the solution online first. Because the more you search online by yourself, the better you will become in searching for solutions, which is actually good. Um, Even when you become a software engineer, you will have to look out for solutions for some bugs or glitches that you would face while development. That is something you will have to do online only now. So it's good to make that kind of habit. It's very simple. Unlast. Last is the value of the previous element that would be present in the final array. And um, basically, like when you pick up this guy, then I will set last equal to 4 so that I will search in the array to find out the next guy which is greater than 4. I'm iterating over the array. Whenever I find an element that is greater than equal to last, I this very short here for this problem. And I hope the logic also sounded simple. can you explain the hints of the question? I saw them after the one place. Okay, let me see the hints also. Iterate backwards, and can you remove the largest element in the array? Is that ever helpful? Okay, so it is going in the other way around. The problem hint is saying that like earlier we had realized that we can't make the array element greater. If you have, let's say, an array like 4251, you know, uh, the problem is basically just going in this way. Check these two elements. If you have the last guy smaller than the last second guy or something like that, you can't really make this guy larger. The only thing you can do for making the last guy larger is either remove this the words like the problem statement, apply an operation here so that the last guy will become 5. You know, what you want to do is have the largest element of the array at the last position. So another way of thinking about the problem could have been, um, whatever is the largest element in the array, you want this thing to be present at last. So you would apply an operation from here till the end of the array. Now this element would be present at last. So you would just try to do the same thing for the rest of the array on the left hand side. Keep on doing it until the array becomes non-decreasing. There are too many ways of thinking about this problem. So, you may find some more solutions online. Okay, let's move on to the next problem then. Oh, by the way, talking about the time complexity. The time complexity is simply big O of n here because we just have a for loop of size n. The space complexity is big O of 1 because we are not having any auxiliary space. So let's move on to the third problem now. Mm, yeah. So the third problem says we have been given an integer array nums with positive integers and a positive integer k. We are allowed to perform an operation once on the nums array, where in each operation um, you can remove any non-overlapping prefix and suffix from the nums such that nums becomes non-empty. So let me explain this part first. You have an array and you have been given an integer k, and you are being told that there is a kind of operation that you are permitted to apply. In the operation, what we do is uh, we choose some prefix and some suffix, and we delete the whole prefix and the suffix. There is a condition that the prefix and suffix should be non-overlapping, and when we remove these elements like the prefix and suffix, the remaining array that we have should be non-empty. Basically, there should be at least one element left. Or in simple terms, in simpler words, you can say the problem is indirectly telling you that in the operation you will just choose a subarray. है ना? A subarray is nothing but an array with some prefix and some suffix removed. So we just have to choose a subarray. And you need to find the x value of nums. Yeah. So whatever array we had earlier, we have to find out the x value of the array, which is the number of ways to perform the operation so that the product of the remaining elements leaves a remainder x when divided by k, which means um, the problem is asking like the um, x value for an array would be the number of ways of applying the operation such that the product of the remaining array um, leaves a remainder k when divided by, sorry, leaves a remainder x when divided by k. That is uh, known as the x value for an array. Now we can make it simpler. Like we can make this language simpler for us. The number of ways of applying an operation, this is basically can be said as number of subarrays, है ना? Because um, whenever you apply an operation, you will be left up with a subarray. For all the different ways of applying operations, you will be left up with different subarrays of the array. है ना? If you apply an operation on by removing these elements, then you would be left up with this subarray. If you had to remove this part and this part, then you would be left up with this subarray. So basically, this is indirectly asking you the number of subarrays whose product, and basically the product of the remaining array is nothing but the product of the subarray, leaves a remainder x when divided by k. This is like if the product is, let's say, p, then p mod k should be equal to x. That is what they are asking. How many subarrays are there such that their product mod k is equal to x? And what we have to do is we have to return an array result of size k such that result of x is the x value of the nums for all x in the range from 0 to k minus 1. So we have to return an array of size result where result of x is basically telling us the x value. Let's say if x is equal to 5, or maybe if x is equal to 2, then we have to tell how many subarrays are there such that the product of, like the product for these subarrays mod k is equal to 2. So if you have an array like 1 2 2 1 2, then when x is 2, the subarray like this one, this one, this one, this one, this one, or this one, they have their products equal to 2. है ना? If k is something like k is 5, then their product mod 5 is coming out to be 2. So that's it. In the problem statement, like in the problem, we would be given k and t array as input, and we will have to find out the x value for each possible value of x from 0 to k minus 1. And the constraints here were pretty decent. Nums can be as large as 29, and nums dot length can be as large as 25, and k can be as large as 5. So k is pretty small here. Can you explain the length of the question? Okay. Yeah. So guys, whenever you have an array and you want to find out count of um, subarrays with some condition, right? Whenever this thing happens, you have to find out the count of subarrays which satisfies some condition. So here you are having two things. A subarray is nothing but like a subarray has some starting point, let's say L, and some ending point, let's say R. है ना? So you are having these two variable things. You have to find out all the combinations of L comma R such that some condition is being satisfied for all elements from the Lth chi till the Rth chi. है ना? This is the thing. This is the type of problems that we have a lot of times. So what I generally do in this kind of problems is fix the value of R, L. है ना? Like if you have two variables, it would be more complicated. So just try to think. If I fix L, or maybe if I fix R, basically if I just say, like now if I say find out the number of subarrays that have this guy as the ending point, maybe R is 7. So the number of subarrays ending on the position 7 with remainder x equal to 2. If I say something like this, or maybe if I say something like I have fixed my value of R. So basically now what I want to do is find out the um, number of subarrays with remainder x for all x in the range from 0 to q. है ना? So it would be like for all of these arrays, this array, this array, this array, this array, this array, and so on. For all of these arrays, you would know something like, let's say you have an array count, where count of x tells you the number of, maybe let's name it as count r of x, uh, number of subarrays with remainder x, number of subarrays that end on r, index r with remainder x. And if you have something like this, then can I say that my result of x would be nothing but the sum of all count r of x for all the r in the range from 0 till n minus 1? Guys, do you agree with it? And please give me some live feedback whether this is looking too complicated or is it looking good. By the way, let me do a recap as well, a small recap. What I've said is whenever you have a problem like count of, you want to find out the number of subarrays with some condition, the thing that you would really want to do is you would like to fix one of the variables, either the starting point of the subarrays or the ending point of the subarrays. And then for this, let's say you have fixed the ending point, find out the number of subarrays ending at this position, which satisfies the condition. Then with the all the information that you would have for all the subarrays ending here, you will try to find out the number of subarrays that are ending on this index, that is r equal to 8 now, with which satisfy the condition. Then you would like to find out the number of subarrays ending at r equal to 9, which satisfies the condition, and so on. You would like to do this thing. And your answer would be nothing but the sum of all of um the subarrays. Like uh, for any subarray, either it would end on this position, or it would end on this position, or it would end on this position or something. So every subarray would have been counted whenever you would have been considering the subarrays ending at this position or this position and so on. So this is a very common way, a very standard way of solving problems where we have to find the count of subarrays with some condition. So we will just try to do this thing here also. Um, Now let's say you know count of 0, count of 1, count of 2. For now, let's assume k is equal to 5. And this was r equal to 7. So for count for r being 7, you know about all of these values, you have already calculated them. And now you want to find out for count 8 of 0, count 8 1, count 8 2, count 8 3, and count 8 4. So see, um, let me show. Um, Now what you want to do is Like these values are actually telling you about all the subarrays that are ending on the element 7, है ना? The starting points can be anything in this range, है ना? From 0 till R. Now, for these people, like what are these arrays? Either the array will start from here. So you know about the product of the array from here till here. Like um, basically the thing is all the subarrays. Let's say the value here is 2. Then all the subarrays which had the product from here till here equal to 1, है ना? With all the subarrays that had the product till this point equal to 1, all those subarrays now will have the product till this place being equal to 2. Like 1 was the product of all the subarrays ending at this position. Let's say there were 7 subarrays who were ending at this position with product 1. Now for all those 7 subarrays that ended here with product 1, if you add this extra element, then you will have all those subarrays go till this position and they will end at the place r equal to 8, and their product would be nothing but their product which you are talking about 1, and this guy would be multiplied, that is 2. So the new product would be actually this count of 2. So in simple words, what I want to say is you can just say that uh, you don't have to find out the count of all the subarrays ending at this position by checking like this. Instead, you can just say that, hey, my value is 2, the value of the current element is 2. So if there were like 5 subarrays with product x, if there were 5 subarrays ending on the index r with product x, then x into 2 would be the product for um, all the subarrays with the same starting point. Like if there was a subarray starting from here and went till here. Now if it goes till here, then the product would be x into 2, right? And then we will do the mod k thing because we want to keep track of only of the remainder only. So we will find out the you will just find out that, hey, there are if there were if there were 8 subarrays with the product x, now there are 8 subarrays with this product for the value r equal to 8 for the ending element at the index 8. So in this way we can just run a for loop here for each x from 0 to k minus 1 and update this thing in the next array. So here in this case, it comes out to be 2 if x was 1. If let's say x was equal to 3, then 2 into x would be 6, and 6 mod 5 will come out to be 1. So this guy would be modified in that case, and so on. So guys, is it making sense? Somebody is saying we use the logic that if we mod any subarray with k, the mod will be minimum number of subarray mod k. This is, I think, completely wrong. If I'm understanding what the same thing that you want to say. If you're saying that for a subarray, um, the mod of the product of the array with k would be equal to the minimum element mod k. Then what about the case if k is 3 and the elements are 2 and 2? The product here would be 4. Modding it with k will come out to be 1, right? Whereas the minimum element is 2. 2 mod 3 is coming out to be 2. I'm not able to understand. Can you explain with an example? Yeah, I can explain with an example. Oh, by the way, um, many people would say that this is a DP problem. And in fact, what we are doing here is nothing but dynamic programming. But while solving the problem, I did not think about it with a dynamic programming mindset. So that is why I did not use the word DP till now. But since I'm done with the part of explaining the whole problem, so I'm telling about it. Now I will just do a dry run and some recap. So let's take an example, maybe 1, 2, 3, 4, 5. Let's say the array is 1, 2, 3, 4, 5. Now what I'm saying is, um, guys, I want to, let's say, find out the number of subarrays here, which whose product mod k comes out to be equal to 1. Can I say that for finding the total number of subarrays with this condition, find out the number of subarrays which end at this position, which satisfies this condition, then find out the number of subarrays that end at this element and satisfies this condition, then find out the number of subarrays which end here, and find the total number of subarrays which end here with this condition satisfied, then with this element, this element. Then like doing this will cover all the elements, all the arrays. है ना? If you just sum up whatever you got from these ending positions, you would have actually got the total number of subarrays satisfying this condition. Do you guys agree with it? First, tell me this. Karan, Hanania, Honey, please confirm. Okay, great. Yeah, so you agree that this will cover all the subarrays, right? Now, now if I want to find out the number of subarrays that are ending on this place, how will I find it? Like the number of subarrays with product mod k equal to 1 and they end here, how will I find it? One way is I can just start to run a for loop from here till the left side. है ना? To just find out um, the product of all the subarrays, like the products for all the subarrays which are ending here. One subarray is this guy, one subarray is this guy, one subarray is this guy. Right. This is one way. This is one possible way. Another possible way is um, you see this subarray that you had and this subarray that you had. It is nothing but this is nothing but this subarray plus this guy, or this subarray plus this guy. Right. This subarray is only this. As for this subarray, it is nothing but this subarray plus this new guy. है ना? Now, the thing that I want you to notice is this subarray and this subarray. They have already been covered when I wanted to find out the number of subarrays ending at this position. Those subarrays have already been covered there. So, what if I say that the subarrays, like the subarrays that ended on this position were 2 and 1 comma 2, right? So what if I just say that if I knew about their products, if I just knew that there is um, a subarray with product 2 and there is another subarray with product 2, I don't really need to go on the left hand side to find out the products of subarrays ending here. If I just know that there is a subarray with product 2 and there is another subarray with product 2, I can multiply 3 and just say that um, whatever subarray was there with the product 2, if I multiply 3, the product here 6, there must be a subarray which had the product 6, right? If I multiply 3 in this and get 6, then I can definitely say that, hey, there must be a subarray with which had the product 6 if I had went to the left hand side to calculate it. Now with just two elements here, this might not make much of a sense, but if you think from this perspective that there are like 1 lakh elements here, let's say 1 lakh elements here, and then there is the guy 2 here, and then there is the guy 4 here. Okay, and there are too many elements again. You want to find out the number of subarrays which are ending on this position, right? The number of subarrays that are ending on this position. Um, and regarding that, all you want to do is all you want to find out is the product of all those subarrays. So the first way is obvious. Just find out all the subarrays that are ending here. One subarray you will have is just 4. Then you will add this guy and you will say that, hey, another subarray is 4 comma 2. You only care about the product, so you will only care, you will just only mark it. You will say that count of 4 is 1. Then you got this, so you said count of 8 is also 1. Then you went here, you got another subarray, you got the product, marked it, then you added one more element, then you added one more element, then you added one more element, and so on. You just did this thing. So you had to make 1 lakh iterations here. Now what we know is we did not really have to keep track of the complete product. We only cared about the modulo thing. So like you know, you only care about the modulo thing. So there are only 5 possibilities: 0, 1, 2, 3, and 4. These are the only 4 remainders that you may have. है ना? Like you could just say that count of 4 should be marked as 1. And then when you reach to this position, instead of saying count of 8 equal to 1, you will say count of 8 mod 5, that is 3, equal to 1. Right? We only care about the remainders. So everything is fine till this point as well. Now, the thing I'm saying is you have a lakh subarrays here. Instead of iterating over all of them to find out the frequency of all the products, what I'm saying is you already know about the frequency of all the products of the subarrays which are ending here, right? You know there are 1,000 subarrays with product 0. There are 98,000 subarrays with product 1. There are 500 subarrays with product 2, and so on. So now since the value is 4, can't you just say that, hey, all those 1 lakh subarrays which ended here and had the product 0, all those 1,000 subarrays, um, similar to them, there will be this for all of the corresponding starting points, there will be this subarray. And the product of this subarray would be nothing but the product of this subarray, which was, let's say, 0 here, multiplied with 4. है ना? So I can just say, I know the number of subarrays with product 1, sorry, with product 0. So there will be 1,000 subarrays with product 0 ending here also. I know there are 98,000 subarrays with product 1 which were ending on 2. So there will be 98,000 subarrays with product 4 which are ending here. है ना? Like at least that many subarrays would exist. There will be one more subarray, that is um the subarray starting here and ending here. This subarray would not be counted earlier because the starting point and ending point right now are equal. है ना? So did you guys understand the idea now? Like, did it make sense now? Guys, at least tell me. Okay, great. There is somebody, and the ones who had asked me to do the dry run, they are not even replying. So, like, did they leave or something? I don't know. By the way, talking about the dry run thing, um, doing a dry run of this approach would be just troublesome, and I don't think it would help much because creating all these arrays will take a lot of time and it does not look productive. Like, this is the way in which I do the thought process. And if it is something that you have not done earlier and you're feeling it to be confusing, then what you need to do is after the PCT, just try to spend a lot of time in understanding this and um, just try to use your extra like existing knowledge to have a similar approach, right? In that way, you will have a better understanding. You will be able to solve problems with this kind of approach by yourself as well. If you try to do it yourself. What if K was bigger? See, if K was bigger, in that case, here right now we are having only five remainders, five possible remainders. If K was bigger, then we will have more possible remainders. So if K is something like even 100, if K is something like even 100, then depending upon the value of n, you may or may not be able to apply the operation. I think you will still be able to apply the operation though. Yeah, you will still be able to apply the operation if K was something like um, less than equal to 100 for the constraint where n is less than equal to um, 1e4 or something, but it will have a chance of TLE. I mean, any similar problems to practice this? I can't remember for now. I can't remember for now. Okay, so guys, let me show you the code. The code is very simple. Um, I created a vector for answer that I will have to return at the end of the day. And I created a count array, basically this thing. So if you want, you can actually create a 2D count vector where count of Rx will tell you the number of subarrays ending on index R such that the product of those subarrays mod k is equal to x. Either you can create this kind of count array, and if you're thinking in the DP perspective, then it is basically just a DP state. If you had got the intention of DP, then the problem would have been um, quite straightforward with the state and all. Um, but even if you then don't know about DP, you have never heard about DP, you can still solve the problem. Um, I discussed that way, like how to solve the problem even if you did not know about DP. Do a complete dry run on the input. Okay, so let me do a dry run on the input first. Maybe let's take this example or no. Let's take this example. Um, I'm not taking the next example because it is just having too many zeros and only three subarrays are there with remainders 1 and 2. So this is a better example. 1, 2, 3, 4, 5, and k is 3. Okay, so here see. Initially, initially the count array um, will have 0, 1, 2, all being zeros, right? There can be only three remainders here because k is 3, so there can be only three remainders, either 0, 1, or 2. Remainder cannot be greater than equal to k, of course. So when you add this guy, when you try to find out all the subarrays ending till this position, um, the count for one would increase to one, right? There was nothing, like there are no other subarrays, so this is the only subarray that you will have. Now, when you want to find out for all the subarrays that are ending here, so there is only one subarray that was ending earlier at this position, है ना? Like you won't really care about the number of subarrays that are ending at this position. In reality, we'll just go to this count array. You will see there is one subarray with product one, right? When you talk about the subarrays ending at two, so whichever subarray had ended at one, it must have a starting point. So for that starting point, when two becomes the ending point, when you talk about when you consider this subarray, the product would be nothing but this, the basically this thing, the product that you had for this subarray, that is this, multiplied with two, है ना? And the number of subarrays with the product one were one. So we will just increment this guy two with one. You will, let's say, have um, new count array. Right. Initially values were zero. So now you did put one here. Nextly, there is just one subarray which is ending at two and starting from two itself, basically the current element itself. So you will have two subarrays that are ending at this position, both having the product two. So this thing will become two, right? Now let's update the count array for this. Now we have count of two here, which is 0, 0, 2, right? Now when you want to find out all the subarrays that are ending at this position, you will just go over it again. The subarrays which had the product 2, when multiplied with 3, the product will become 6, which when you do modulo, like when you do 6 modulo 3, you will find 0. So you will just update this 0 guy, like you will increment the 0 guy with this value, that is 2, right? And the array is starting and ending at 3 itself. So 3 modulo 3 is 0, so this would be incremented once more and it will become 3. Now let's just copy paste the data. 3, 0, 0, right? Now the number of subarrays that are ending here. So for those subarrays, when you do 0 multiplied with 3, sorry, 0 multiplied with 4, what do you get? You get 0. So on the position 0, just increment this value, that is 3. Now the subarray that is starting and ending at the same place, that is 4. 4 modulo 3 is 1. So this will be updated here. Now you will just copy paste the data here. Now we will talk about the number of subarrays that are ending at this position. So consider this product 0, like the subarrays that are having the product 0, that is this subarray, this subarray, this subarray, right? For all these subarrays, you will just have the new product as 0 as well. For the subarrays that had product 1 till this point, that is the subarray, will now have the product 1 into 5 mod 3, that is 2. So 1 would be incremented here. And nextly talking about 5 itself, 5 mod 3 is again 2. So this would be incremented once again and it will become 2. So just update 3, 0, and 2. Okay. Okay. So I forgot to do about one important thing. That was like in the dry run that I did, I forgot to actually keep track of the values of count for all of these positions. So we need to add it as well. Let me just mark what were the values. For this position, we had zero number of like 0, 1, 0 here. For 2, we had got 0, 0, 2. For the 3 guy, we got 3, 0, 0. For the 4th guy, we had got 3, 1, 0. And for the fifth guy, we got 302. So if you add these, you will get 9, 2, and 4. So answer should be 9 to 4. That is here, 9 to 4. Okay, so Ayush, now is it clear? I'm not sure if dry run did help much or not. Okay, it did help. Yeah, then that's nice. Maybe I should do more dry runs in future. Uh, this is actually a benefit of live classes. Like you can actually tell me the way in which you want me to teach. है ना? If you guys give me the feedback actually during the live class, or even after the class, if you write your feedback in the comment section that you want me to explain in this way, then in the future videos I can actually do that thing more. Since now I'm seeing that you guys prefer dry runs more, then maybe I can do dry run more times. Even if I don't feel it to be very useful, I can at least spend some time at doing the dry runs. Right. Okay, so we will come to the fourth problem. Let's wait for 2 minutes. Let's have a 2-minute break and then we'll do it. By the way, guys, I do prefer feedbacks, even if it's live or not. Um, the only thing that I don't like in terms of feedback is something like if somebody comments bad video, then I don't really know what thing you didn't like. You know, it does not help at all. If you actually don't like something, then you can mention that specific thing. That hey, it would have been better if you were teaching a little fast, or if you spent more time in explaining the intuitions, or if you say that hey, your intuitions are a bit too complicated for us, so maybe spend less time in explaining the intuitions and um, tell more about the approach. You know, you can tell about all these things. Okay, so let's go to the fourth problem. The fourth problem is going to be a little more complicated. This is a follow-up problem of the third problem. By the way, before starting, I would say for the fourth problem, I do expect you guys know about segment trees. Like these are the prerequisites. If you don't know about any of the prerequisites, then I would um, recommend you to just go on and prepare yourself with the prerequisites first. Once you are really comfortable with the prerequisites, maybe then come back to the problem. Until then, you can just bookmark the problem. So you should know about segment trees. Then there is a problem of uh, there is a problem which can be solved using segment trees where you are being given um, any subarray, let's say L comma R, and you will have to tell the maximum subarray sum of any subarray contained in the range from L to R. है ना? Do this problem as well. And apart from this, you should have solved the C problem. Okay, solve the C problem. Is it a need to learn if we know about segment trees, then is it a need to learn about segment trees? No. If you know about segment trees, that's fine. You don't need to know about Fenwick trees. Um, the only advantage of Fenwick trees is that um, it has a very short code. You can code it very easily. But if you know about iterative segment trees as well, then that is also something you can code very fast. Uh, like it might sound a little crazy if you don't know about like if you have only learned about the recursive segment tree, then it might sound a little crazy to know that iterative segment tree can be written in like 35 lines or 30 lines, or maybe even less than that. So basically in like 30-35 lines or less than that. Let me check the number of lines I have here. 26 to, yeah. So in like uh, around 25 lines, you can implement a segment tree. And iterative segment tree is significantly faster than the recursive one also. Coming back to the prerequisites, you need to know about segment trees. You need to have solved this problem. Like even if you have not solved the problem, you can still solve this D problem. But it is good to first of all do the theory work, the standard problems. You need to have solved the C problem. And I think that's good enough. I'm expecting that in general, people would be like the people who would be attending the PCD would be greater than equal to expert, since this is a hard problem. Baki, it's up to you. Okay, so the problem says, as earlier, you are being given an nums array, and this time, instead of just the array, you are being given some queries as well along with the array. In every query, you would have four things. First of all, an index, a value, a start point, and a value of x. So what you have to do is, on the index, whatever index that is being given to you, go on and update the value to the new value. So let's say if index value is, let's say, 1 2, then what you will do is you will just update nums of 1 to 2, and in the x value, like when we used to calculate the x value, what did we used to do? We used to remove some prefix and remove some suffix. है ना? Basically, we used to find some subarray, which like whose um yeah, we used to find the number of subarrays, right? In one operation that we used to do, we used to remove the prefix and suffix. So for now, we are being given the start point. So what we will do is we will remove all the elements from 0 to start minus 1. Right. So we don't really have it as our choice now on what prefix we want to remove. There is gonna be some prefix, uh, some value given to us that you have to remove this prefix. Right. Now what we want to do is we want to find out the number of um, ways of removing some suffix such that the product want k comes out to be x. That's what we have to do for each query. Or in simple terms, you have to find out the number of subarrays that are starting from this index. The number of subarrays that are starting from this subarray, this index, and the product of them is equal to like find out the count of such subarrays. And yeah, in each operation, you will have to do this um, update thing. And when you update in one query, the updated value will stay persistent for the next queries as well. So if the array was, let's say, something like 1 2 3 4 5, and you update this 3 to 2 in first query, and in the second query you updated 4 to 5, then the array will become 1 2 to 5 5, right? um it will become 1 2 to 5 5. I hope you're fine. So this value will stay persistent. That's it. So right after reading the problem, for now I'm gonna be telling you about my intuition. So right after reading the problem, the idea which I had was, since I had solved the C problem, I already had an idea that hey, earlier I was just keeping track of the um something like count of ix that tells you the number of subarrays ending on the index I with the product mod um, k equal to x, है ना? You had this kind of arrays. So just create this kind of arrays for prefix and do the same thing for suffix. And I was thinking in this line, but the problem was whenever I update an element, I can't really update both the prefix and suffix arrays because it would be very time inefficient. It will take big of n time to just update after each query, update all these values and all these values. So I started to think about the segment trees, because like the idea is that I have some updates which I'm making in queries, and I was trying to apply something similar to the previous solution of the C problem in this D problem. I'm not telling you about the whole idea that I had for solving it with prefix arrays, because I did not really apply that idea. For now, I'm just telling that I was trying to apply prefix and suffix arrays, which did not really work out. And I tried to think about segment trees then. So once you get the idea of segment tree, then what do you want to do? Now let's start to understand from this place. What I want is um, a node in a segment tree should be able to tell me, like, if this is my whole array, and this is the start place, and I want to find out the number of subarrays starting from here with um, prefix product mod k equal to x, something like that. Basically, product mod k equal to x, number of subarrays starting from here. Um, then what I want is a node in a segment tree should have something like count of x that tells you number of prefixes of the range. Basically, the range whatever range the node of the segment tree is containing. For this range, what is the number of prefixes such that the product of the prefix mod k is equal to x? I would create something like this. I would have this value in the node, and if you have this kind of value in the node, then um, you can answer the queries with your segment tree. Now, the thing is, you need to have good understanding of segment trees. Otherwise, this thing would definitely be looking complicated. Like, to be honest, if I had just learned about segment trees and I had been doing this kind of a problem, then it would look complicated. It's completely okay. If you feel it to be very complicated, then just skip the problem for now and solve some more problems of segment trees. Go to the EDO section of code forces first. For now, I'm assuming that the ones who would be coping up would be the ones who have good practice of segment trees. So, like what we do in segment trees, we think what information that we want to store in a node, and then we think on how we can um, merge two nodes. You know, how can we merge two nodes to create a bigger range? This node has some range, this node has some range, and the parent node should have a bigger range covering both of these. So how will you merge these? So see, um, all the prefixes of the left part are gonna be the prefixes for the parent node also, right? So first of all, this count array for the parent node can be filled with the child node of the left side. Then there will be some prefixes like this, in which this whole range is covered and some prefix from the right child is being covered. So if you want to keep that thing also, then you do need to know about the product of this. Basically, see, if there are like 5 prefixes in this right node with product 2, the product is 2. There are like 5 prefixes like this, and the product of this whole range is, let's say, 3. Then in that case, there will be five prefixes, like all these five prefixes would be present here as well with the product sets, right? So what information do I need for every node? One of them is the product of the whole range, and the other one is the count of the prefixes with um, product mod k equal to x for each x, right? And the merging part is pretty simple. Um, the product of the parent would be nothing but the product of L, the left node, multiplied with the product of the right node. As for the count thing, initially the count of the parent would be equal to the count of the left child, right? The count of the parent node would be the equal to the count of the left child. Nextly, you will just run a for loop of x from 0 till k, and you can say um, count of x into product of the left guy, L dot dot mod k, um, should be incremented by um, r dot count of x. So what this thing means is that if there were like um, r dot count x number of prefixes in the right node with product x, now there will be this many prefixes with this product remainder. How will we handle the case you told that would give TLE if K was pretty large? See, if K was pretty large, then some other constraints would be there in the problem, or maybe n would be smaller. Like the problem will do something, the problem setter will do something so that the problem would be solvable. And the approach that would be used there can be anything depending upon the constraints. So for this problem, all we have done is we just um, used a segment tree for finding out x value for n. Uh, Basically, we have used a segment tree to make some updates, and with the help of segment trees, now what we can do is for any the x value of that subarray, right? We can find out the x value for any subarray now with the help of segment tree, and we can make the update queries as well. Whenever we make an update in the segment tree, all that would happen is some node would be updated. When the node is updated, it will have a new value. Then you will update the parent depending upon the two children it has. When this would be updated, then it will go to its parent and it would be updated, and then its parent would be updated, and so on. You know, like uh, I think this problem should be doable right now. Um, Considering the ones who would be watching right now are greater than equal to expert. In case if you are actually smaller, like if you are actually someone below expert, maybe something like pupil or specialist, then you don't really need to worry even if you are not able to solve the problem, because there are very less chances that you will get this kind of a problem in code forces. And even if you get this kind of a problem in lead code and you are below expert, then um, there is still a good chance that you won't be able to solve this kind of problems. So right now, what I would suggest is that you should go and try to get a better the prerequisites, mainly the segmentary part. Okay, so let me show you the code. So in my code, I have a generic segment tree, and the implementation is iterative. So this is also something I should add in the prerequisites. Maybe just search on internet generic segment trees. Just search about this on internet. You will find various resources regarding the implementation. If you are interested, you can learn about the iterative implementation of segment trees also, but it's not really necessary. Even if you just copy paste this code, it would be still fine. Nextly, what I'm doing here is um, I created a segment tree. Inside the segment tree, I required the value of k, so I created a global variable value of k, which I'm updating here. And I'm going for each query. I'm find out the number of prefixes in the subarray from start to n minus 1 um, with the remainder rem, that is basically x here. And then I'm just pushing it back into answer, and then I will return the answer at the end. And inside the segment tree, what I've been doing is let me give you an overview about what's a node. So this node is basically gonna be the nodes in the segment tree. Like you have multiple nodes in segment trees, right? The two things you see here are the information that I'm storing in the segment tree. As we discussed, I will store the product and some count array in the segment tree, the information. So this is this part. Then there is a constructor for the case of a node that is not going to be utilized. Like you will have, you see, in a segment tree, even if you have learned about the recursive segment tree, you must have heard about neutral data or neutral nodes. So this constructor is basically for the neutral nodes. Let's say if I'm gonna be using segment trees for finding sum, then in the neutral node you put the value sum equal to 0. If let's say you want to find out the max value, then you put mx value to be a very small value, something like minus 118. If you want to find out something like XOR, then also you keep the XOR in the neutral node equal to 0. If you want to find product, then you keep the product value equal to 1 here, and so on. So basic idea is if you have a normal node and you merge it with a neutral node, then you will just get the normal node back, right? If this is a neutral node and it is being merged with some node, let's say some node u, then the merge of all both of these two nodes would be equivalent to the node u. Then this is a constructor for the leaf nodes. This is the constructor for the leaf nodes, which would be created with the value of the array here. So for the leaf nodes, all the values of count should be 0, all except the product, basically the actual value of the array. That's it. Nextly, while merging two nodes, the product would be nothing but the product of the left guy, the product of the right guy. And actually, I'm saying product, but I'm keeping track of product mod k, right? I'm keeping track of the remainder. So L dot prod into R dot prod mod k. Then I'm going for x all over from 0 to k. Result dot count would be incremented in these two ways. This first guy is basically talking about the prefix from the left node, and this is talking about the prefix in which the left node would be completely covered and the right node will have some of its prefix being covered. And then there is this update function in which I'm just saying that, hey, create a new node. That's it. So yeah, that's it for the complete problem. Where to learn segment trees? Any good resource? Yeah, there are multiple good resources. First of all, there is the edu section on code forces. There is CSES, and you can go to CP algorithms if you want for the theory part. These two will have good problems to practice, and CF, like the editor edu section in CF, will have theory as well. This will have a lot of theory. CACS has a lot of problems, good problems. In my opinion, doing all of this should be enough. If you just go over these two resources for practicing and CP algorithms for theory thing, it would be more than enough. And if you have not done all of this till now, then I would recommend you to just do this first. Okay, so thank you for attending the PCT and bye bye.